Hi, welcome to my video on review 2 of quadrilaterals, and that's the videos numbers 11 to 19 that I do a review on. Note again, because it's proofs, I'm not treating it as a quiz where you give scores. Just try to see if you can answer the questions correctly. Number 1, we have a diagram. X, Y, P, Q are the midpoints of AC and AB and BT and CT respectively. Prove that X, Y, QP, X, Y, QP is a parallelogram. And to prove a parallelogram, we need opposite sides parallel, opposite sides equal, opposite angles equal, one pair of opposite sides equal and parallel, and diagonals bisect each other. So let's see how we're going to, let's write down the given first. X, Y, Q, P are midpoints of AC, AB, BT, and CT, and that's the given. And because we have midpoints, now we have X and Y are midpoints right here, that means that X, Y is parallel to CB, and X, Y is a half of CB. So in the triangle A, C, B, these are the midpoints of this segment. X, Y is parallel to CB and a half of it. And that's because of a theorem that we did. It's called the Midline Theorem. Also, we have in this triangle TPC, PQ is parallel to CB and a half of it because these are two midpoints of these sides. So PQ is equal to a half of CB, and PQ is, let's make that is parallel to CB. And again, we have midline there. We're just going to do ditto marks. So as a result, if XY is parallel to BC and PQ is parallel to BC, that means that XY is parallel to PQ. And the reason, if two lines or segments, let's say segments, if two segments are parallel to the same segment, then the segments are parallel. And number 5, notice that we have XY is a half of BC, PQ is a half of BC, so that means XY is equal to PQ, because XY is a half of CB, PQ is a half, so half of CB is this statement and this one, so XY is equal to, and that's a transitive property. So notice now that we have XY is equal to PQ, XY is parallel to PQ, so that means XY, QP is a parallelogram. The reason, if one pair of opposite sides of a quadrilateral are parallel and equal, then the quadrilateral is a parallelogram. Okay, don't forget that you can pause your video and do your proof to see if you understand. Remember, proofs are not easy to do. A lot of students have trouble. Number 2, we have a diagram here, and we're given that PQRS is a rectangle. PQRS, this is a rectangle. And it says that YS is equal to HR. So these two segments are equal. Prove that XPQ is isosceles. The triangle XPQ is isosceles. So this is an isosceles triangle. Two sides have to be equal. So how does the properties of a rectangle help me to do this proof? Again, if you pause the video and worked it out, great. Here we go. I'm going to name 1, 2, 3, 4, and name this one 5 and 6. I'm going to use the numbers because it's easier than using three letters for angles. So we're told that PQRS is a rectangle, and that's given. And as a result, if that's a rectangle, angle 1 and angle 3 are right angles. Definition of a rectangle. A rectangle is a quadrilateral with 4 right angles. And that means that PS is perpendicular to YH, and QR is perpendicular to YH. Definition of perpendicular segments or lines. If you've got right angles, the segments are perpendicular. And as a result, angle 2 is equal to angle 4. Or should I say, because angle 2 and angle 4 are right angles. Again, definition of perpendicular segments. And hence, angle 2 is equal to angle 4. All right angles are equal to each other. Now we have, let's see, we have PS is equal to QR because the opposite sides of a rectangle, that's an angle, rectangle, are equal because a rectangle is a parallelogram. Opposite sides equal. And number 7, YS is equal to HR, given. And number 8, that means, let's see, we have PS is equal to QR. We have angle 2 equals angle 4. So we have the triangles congruent by SAS. So the triangles are congruent. What triangles? PSY is congruent to QRH. And that's side, angle, side. Congruency. Number 9, that means that angle Y is equal to angle H. Angle Y is in triangle PSY, and angle H is in QRH, and that's CPCTC, corresponding parts of congruent triangles congruent. Number 10, we have PQ is parallel to SR, opposite sides of a rectangle are parallel, and as a result of these two lines being parallel, That means 5 is equal to angle Y, and 6 is equal to angle H. And there's a PLT, but these are corresponding angles because they're on the same side of the transversal. Corresponding angles equal. And as a result, we have, notice, right here we have Y is equal to H. So we have Y is equal to H in number 9. 5 is equal to Y. 6 is equal to H. That means that 5 is equal to 6. Transitive property. Spell it right. Transitive. Transitive property. And that transitive property is in number 9 and 11. We have XP equals to XQ, and that's the converse of the ITT. It's the converse of the isosceles triangle theorem. That is, if two angles are equal, then the sides opposite them are equal. Number 14, triangle XPQ is isosceles. And the reason? Definition of an isosceles triangle. Isosceles triangle is a triangle that has two sides equal. So, hopefully everything is going okay. You're doing your proofs. Now we have a third one. Lots of proofs. But each of the proofs that I'm doing is in the order of the videos. So this time I'm going to do a proof related to a rhombus. So ATCV is a rhombus. ATCV is a rhombus. And we had to prove that BA, which is this one, equals BC, which is this one. So we probably have to get, as I can see, that the triangle ABT and CBT, if we can get these two triangles congruent, then we'll have what BA equals BC. So how do we do the properties of a rhombus? Well, the first thing I see is a rhombus. I see that these two sides are equal. So let's write down that ATCV is a rhombus. And that's a given. So we have that TA is equal to TC. Definition of a rhombus, which is all sides equal. Number 3. Now we have that. And what else do we have in a rhombus? I can see that I already have BT is equal to BT because it's a common side. So I have BT equals BT. It's a common side to both triangles. So I have to get this side, so I need an angle. I can't have this angle right here, this one, ABT, because it'll be an ASS. I can't have this angle here at A because it'll be an ASS. So I must get this angle right here at T. So let's put some numbers in. 1, 2, 3, 4. And here we go. Angle 1 is equal to angle 2 because the diagonal, diagonal of a rhombus bisects its angles, and as a result, now we have angle 1 and angle 3 are a linear pair. Angle 2 and angle 4 are a linear pair. That's the definition of linear pair. Adjacent angles forming a straight angle form a linear pair. That means that angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 4 because of a straight STR straight angle. And 1 equals 2. That means that angle 3 is equal to angle 4 by the supplement angle theorem. So if these 1 and 3 are supplementary, 2 and 4 are supplementary, 1 equals 2, so 3 is equal to 4, supplement angle theorem. So now we have 3 is equal to 4. So now we have enough that we get proved the triangle is congruent. So we have BTA. BTA is congruent to BTC. And that's because of side, angle, side. Congruency. And now we have BA equals BC, BA equals BC, CP, CTC. So hopefully the proofs are going okay. You can organize them correctly after going through all my videos. And number 4, this video is on a square, reviewing properties of a square. So A, we have this diagram. A, B, C, D is a square. A, B, C, D is a square. So we know in the square that we have all the sides equal. We know in the square we have 4 right angles. And we are also given that KD is equal to ND. KD, this line here, so this segment, KD is equal to ND. And we have to prove that angle 1 is equal to angle 2. Angle 1 are in the triangles. So if we can prove these two triangles congruent, then we get 1 equals 2 CBCDC. So we have these two sides are equal because of the definition of a square. All sides are equal. And we have a right angle here. And we have a right angle here. So that means we have a right angle there and there. So we have two sides equal, right angles. So if I had another angle, so I had, why did they give me KD, ND? Oh, so AD is equal to CD. So if I take that off, KD, subtract AD, I'll get KA. And KA is equal to NC. Therefore, the triangles are congruent by SAS, and we get 1 equals 2. So that's the proof. Here we go. A, B, C, D is a square. Given. So that means that AB is equal to AB is equal to CB. Definition of a square. All sides equal. Now we have that KD is equal to ND, ND, given. Spell it correctly. Number 4. So KD is equal to KA plus AD, and ND is equal to DC plus CN, and that's the segment addition property. So hence we have KD, ND is here, they're equal right here, and there they are there, so that means KA A plus AD equals DC plus CN by transitive property. And notice that, let's see, we have AD is equal to BC. Again, definition of a square, all sides are equal. So hence, we have KA is equal to DC by subtraction. Subtraction property. So we have this side equals this side. So notice we have enough that we have to get, no, we don't have enough yet. We got these two sides equal, BA and BC. We got KA equals NC, and we have right angles. Oh, here we go. We need the right angles. So let's put 3, 4, 5, and 6. So angle 4 is equal to angle 5. Definition of a square, which means we have all right angles. Now we have that D, we have a perpendicular here, so AB is perpendicular to K. AB is perpendicular to KD, and we have BC perpendicular to DN. Definition of perpendicular segments. So hence, we have that angle 3 and we have them equal, the right angles. But what I should say here is that, yes, they're equal. I should say 4 and 5 are right angles. That means that 3 and 6 are right angles. Definition of perpendicular segments. Make that an S area here too. And hence, we have angle 3 is equal to angle 6 because all right angles are equal. So yes, 4 is equal to 5. But if I say 4 and 5 are right angles, that makes that perpendicular here. So this makes 3 and 6 because these are perpendicular, and this is perpendicular. This is perpendicular. 3 is equal to 6 because they're right angles. Now I have the triangles congruent. So KAB is congruent to NCB, and as you can see, it's side, angle, side. Congruency, and as a result, the triangle is congruent. We have angle 1 is equal to angle 2, CPCTC. Hopefully your proofs are going well, and if you didn't get it when you pause the video, now you see how the proof is being done using the properties of the square. Okay, let's do more. Number 5, we have this diagram. MATH is an isosceles trapezoid. MATH is an isosceles trapezoid. So, in an isosceles trapezoid, a trapezoid has one pair of parallel sides. Because it's an isosceles trapezoid, the legs are equal, so MH is equal to AT. And because we have an isosceles trapezoid, this angle right here is the base angles of an isosceles trapezoid are equal. So we're also given that FHT is equal to VTH. So this big angle is equal to this big angle. So I can see I have the small angles equal, that's in the trapezoid, and the big angles equal. So if I subtract, then I'll get FHM equal to VTA. And we have FH equal to VT. So that means I want FM equals VA, so I need to get this triangle congruent to this one. So here we go. So MATH is an isosceles trapezoid. Oh, number one. Gotta be careful. Now number two. So we have that. I'm going to put some numbers in here to make it easier to follow. 1, 2, 3, and 4. So what we have is, we have that angle 2 is equal to angle 3. Base angles of an isosceles trapezoid are equal. And we have FHT, angle FHT is equal to VTH. VTH given. Number 4. And as a result, that FHT is equal to angle, FHT is equal to angle 1 plus angle 2. And we have VTH is equal to angle 3 plus angle 4. And that's the angle addition property. These two angles 3 and 4 make up the large angle VTH. 1 and 2 makes up the angle FHT. And hence as a result, angle 1 plus angle 2 is equal to angle 3 plus angle 4. That's transitive. And the transitive property is in 3 and 4. Again, FHT is right here, and VTH is right here. So because these two are equal right here, then 1 plus 2 equals 3 plus 4. And 2 equals 3 up in number 2, so that means 1 is equal to 4. 2 is equal to 3, so that's a subtraction. So we have angle 1 equals angle 4. We have, now as you can see, or should I say, MH equals AT. It's the legs of an isosceles trapezoid are equal. And we're given that FH equals TV. That's a given. So you notice that this triangle is congruent to this one, SAS, side, angle, side. So the triangles are congruent. Triangles FMH is congruent to VAT by SAS congruency. And hence we have FM is equal to VA by by C, P, C, T, C. Hopefully the proofs are going okay and trying to help you understand. But don't forget to pause the video. If you pause the video and work out the proofs beforehand, it helps. When I'm doing them, it looks like they're great, but when you have to think through all the properties, then you got to be careful. Now we have a diagram here, and it says A, B, C, N is a kite. A, B, C, N is a kite. So if A, B, C, N is a kite, we're given that 1 is equal to 2, so there's 1 is equal to 2. Prove that angle O is equal to angle P. Angle O equals angle P. So we have to use the properties of a kite. So a kite has adjacent sides equal, so those BA equals BC, and NA equals NC, so they're equal in a kite. And let's see what happened. What else do we have in a kite? Okay, here we go. And the kite, bisects the angles. So this angle right here is equal to this one, and this angle is equal to this one. And what else do we need? We have to get into this triangle right here, OAB and PCB. So we have these sides equal. So here we go. Again, if you pause the video and look at your proof, there's a kite. So AB is equal to CB. AN is equal to CN. Definition of a kite. That's a kite is two pairs of adjacent sides equal with no parallel lines. So we have BN equals BN, common side to the two triangles. So notice this angle B, this angle is equal to this one is equal to this one. So B goes with B, A goes with C. So BN goes with BN, common side. So we have enough to get the triangles congruent because, there it is, we got a side equal. This is common, so we got this angle A, triangle ABN is congruent to CBN, and the reason is side, side, side congruency. And we have angle 1 equal to 2. We now have those equal, so we need another side or another angle. So what happens is that let's name this angle right here as 3 and 4, and let's name this angle here as 5 and 6. So as a result of we have triangles congruent, we have angle 3 is equal to angle 5, and that's CPCTC. Number 6, we have, again, here we go, we got the linear pair. 3 and 4 are a linear pair. 5 and 6 are a linear pair. Definition of a linear pair. 3 is supplementary to 4. 5 is supplementary to 6. That's because we have a straight angle. Straight angle form 180 degrees, which is supplementary. And because 3 equals 5, that means angle 4 is equal to angle 6 by supplement angle theorem. So 4 is equal to 6. So we have the triangles congruent by angle, side, angle. So the triangle is AOB. AOB is congruent to CPB, and that's angle, side, angle. The T there, congruency. And number 10, angle O is equal to angle P, C, P, C, T, C. So we use the properties of a kite to help us prove the triangle is congruent. Okay, some more. Which quadrilaterals does not have equal diagonals? Well, a rectangle, if you draw a rectangle, notice, because of the right angles, the diagonals are equal. If we have a rhombus is normally squish with all sides equal. And you can see that this one is longer than this one. So the answer is a rhombus. A square got all sides equal, all right angles. So you see the square got the diagonals equal. And an isosceles trapezoid is like this. There's one pair of parallel sides. The legs are equal, so that means the diagonals are going to be equal. So the answer is B. Place always, sometimes, or never in the blank to be true. A parallelogram is always, sometimes, or never. Sometimes. A parallelogram is sometimes a rhombus. If you took a parallelogram and made the adjacent sides equal, you get a rhombus. So all parallelograms don't have all sides equal, but they do sometimes. A quadrilateral is a square if all angles are 90. State is converse. If false, state Y. State Y. If a quadrilateral is a square, all angles are 90. If a quadrilateral has all 90-degree angles, then QAD, quadrilateral, is a square. And that's false. Because if you draw a rectangle, there's a rectangle. Rectangle has all right angles, but it's not a square. It doesn't have all the sides equal. A parallelogram with equal diagonals. A parallelogram that has diagonals equal is a rectangle. So if we draw a rectangle which has 4 right angles, so a parallelogram has opposite sides equal, opposite sides parallel, but once you make it the diagonals equal, like that, then you have a rectangle. Consecutive angles of a parallelogram are x plus 20 and 3x minus 40. Find the measure of each angle. So if we have a parallelogram, which is like this, and we have opposite sides parallel, consecutive angles are x plus 20 and 3x minus 40. So opposite angles are equal. Consecutive angles are supplementary. So that means x plus 20 add on 3x minus 40 equals 180 degrees. 4x minus 20 equals 180. Add the x's. 20 and minus 40 is negative 20. 4x is 180 plus 20. 4x is 200. Divide by 4, and x equals 50. So if x is 50, that means x plus 20 is 50 plus 20, so 70. And 3x minus 40 is 3 times 50 minus 40, 150 minus 40 is 110, which makes sense. I didn't have to do that. Once I got a 70 here, I know this is 110 because these two angles add up to 180. That means that the angles are 70 and 120. So the angles 70 and 120, and opposite angles are equal. So there's another angle, which is 70 right here. There's another angle right here, which is 110, because there's opposite angles equal, and consecutive angles are supplementary. So the angles, the measure of each angle, again, these two are 70 and 110, and the two more angles of 70 and 110. Okay. Again, don't forget to pause the video and work these out. Notice we have a pair of parallel sides. Notice that these two are equal, so that's a midpoint. These two are equal, so that's a midpoint. That means that this segment right here is a median. It's a median, and these are parallel sides. These are not. These two sides are not parallel. So this is the median of a trapezoid. The median is half the sum of the two bases. So that means this median right here is x squared plus 2x is a half of 12 plus 18. X squared plus 2x is a half of 30. X squared plus 2x is equal to 15. X squared plus 2x minus 15 equals 0. Because it's a quadratic, you make it equal to 0. And let's go up here. This is a quadratic, so we're factoring it equal to 0. And this x squared is x and x. The product is, notice we have a 15, so the product is right there, which is negative 15. The sum is right here. Product is negative 15. The sum is 2. So factors of 15 are 1 times 15, 5 times 3. So which pair of factors give you a 2? It has to be a 5 and a 3. But the product is negative, so it has to be a plus and a minus. So to get a plus 2, it has to be a plus 5 and a minus 3. So x plus 5 equals 0. X equals negative 5. X minus 3 equals 0. X equals 3. So we have two answers. So let's check the answers. So x squared plus 2x, we're checking with x is negative 5. Negative 5 squared plus 2 times negative 5. 25 minus 10, 15. Okay, it's all right, because it adds up to 15 is what? 12 and 18 is 30 and a half. It is 15. So let's check with x is 3. So x squared plus 2x, x is 3. 9 plus 6 is 15. So that's okay. So the answers are negative 5 and 3. Both of them are the solutions for the values of x in this equation. Again, sometimes a quadratic gives you two solutions, and it'll give you two answers, but it might not fit the problem. Be careful. Number 13. Again, don't forget to pause the video and work these out. Diagonal of a rhombus forms angles with measures of 4x plus 5 and 2x plus 25 at one of its vertices. If the diagonal is 8 centimeters long, find its exact perimeter. Simplified. Okay, let's see what we have here. We have a rhombus, so let's draw a rhombus. A rhombus has all sides equal, and their opposite sides are parallel. So this side is parallel to this one, this side is parallel to this one. And it says the diagonal of a rhombus forms angles that have measures So the diagonal of a rhombus forms these angles at one of its vertices. So this one is 4x plus 5, and this one is 2x plus 25. But how are we going to, and the diagonal is 8 long. So what are the properties of a rhombus? The diagonals of a rhombus bisect the angles. So 4x plus 5 is equal to 2x plus 25. So when you got a rhombus, these two angles right here, this one and this one, are equal. So if they're equal, we'll solve it for x. So x is 10. So if x is 10, 4x plus 5, x is 10, 45. These angles are equal, so it means that 2x plus 25 is also 45. Let's check. X is 10. That means that really, even though I drew it this way, that means that this is a rhombus, all right, but these angles are 45s. That means that if these two angles are 45s, 45 and 45, that makes this angle 90. That means that's a 90, and that's a 90, and that's a 90. So we have a triangle that has 8, 45, and 45 degree angles. So these two sides are equal. So if these two sides are equal, we can do it two ways, by Pythagorean, or we can do it by what we call, that's n, that's an n, and that's n root 2, because this is n root 2, special right triangle. So that means n root 2 is equal to 8. Divide by root 2, n equals 8 over root 2. Rationalize root 2 over root 2. So n is 8 root 2 over 2. Root 2 times root 2 is root 2. And that gives me n is 4 root 2. And so this side is 4 root 2. This side is 4 root 2. 4 root 2. 4 root 2, because they're all equal. So the perimeter is 4 times the side. So it's 4 times 4 root 2. So the perimeter is 16 root 2. And it's in centimeters. This exact perimeter. Again, notice how it's worked out. Even though I drew it like this, which I had to, because I didn't know it was going to be 45 degree angles to make it a right angle. So that's why I could find the exact length, because I have a right triangle. You could have also done this. You could have also done this one by 8 and 45 and 45. You could have called that x and did the Pythagorean. C squared equals a squared plus b squared. So you would have 8 squared is x squared plus x squared. And you could have got 64 is 2x squared. And you divide it by 2, x squared would equal 32. X would equal plus or minus the root of 32. So x would have been plus or minus 16 times 2. So that's plus or minus 4 root 2. And so x would have been 4 root 2, because your sides can't be negative in geometry. So we could get it this way, by a special right triangle, or we could do the Pythagorean to get 4 root 2. And then 4 times that is the perimeter. So that brings us to the end of this unit on quadrilaterals. And this is the last video to review. If you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, videos, and the content. And that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.